Greetings, salutations, all those nice things. Hope everyone's doing well. This lesson is about trigonometry. Trigonometry is pretty much triangle geometry, if we break it down that way. And we're going to be studying some various things, one relating side lengths, as we'll do with this Pythagorean theorem. We'll also be looking at some new stuff about angles. And that will kind of sum up trigonometry as we do it. So this one might be kind of reviewish because in previous years of study you did look at the Pythagorean theorem, but it's necessary for us to look at just to make sure we have a good, secure understanding about it and how it works. One thing worth noting about the Pythagorean theorem is that it applies only to right triangles. So if the triangle doesn't have a 90-degree angle in it, we can't use the Pythagorean theorem. 90-degree angles will always be indicated with this little square figure. That indicates that that angle measures 90 degrees. That is a right angle, therefore this is a right triangle. Whenever we do have a right triangle, we'll use this statement. A squared plus B squared equals C squared. And that's what's going to be used to link the lengths of the three sides together. A and B are the two perpendicular sides. Those are the two sides that make the 90-degree angle. Which one is which doesn't so much matter as long as those two are the ones that make up that 90-degree angle. C is the longest side. And that's the one that the 90-degree angle kind of opens up to. So whatever the longest side is, that has to be the value of C. So we're going to use this theorem to find side lengths, but we're also going to use it to see if some given measurements do represent a right triangle. For starters, let's determine the measure of the indicated side. And we're going to round to the nearest tenth or 1 decimal place. Here, we know we've got a right triangle because those two sides intersect at 90 degrees. For this, we will then say a squared plus b squared equals c squared. That's the theorem we're working with, and from there, we're going to fill in what we know. We can let one of these sides be A, one of these sides can be B, and then the longest side will be C. So filling in what we know, the A is actually a 6. The B is actually an 8. And this triangle doesn't involve C, but it does have an X. So that's what's going to replace that C. At this point, you can compute these manually or use your calculator and type this directly into it. So type that directly into your calculator, see what you get. Yes, I am waiting. Well, can't tell if you actually did it, but hopefully you did. You should be getting that as being 100. Oops, I made an oopsie right above. Over here, I accidentally wrote x, but it's actually squared. So make sure that gets in there. And 100 is equal to x squared. And to get the x on its own, we need to take the square root. Square root's what's going to undo a squaring. So we apply that to both sides. We put this side into our calculator. We find out what the square root of 100 is. Take a moment, see if you can get what that is, and we'll get a value for x. Hopefully you tried it. Hopefully you got 10. And it's exactly 10, so we don't need to round that. Let's try this next example. We set up the same way. We know it's a right triangle because of this right angle here. So we come in, we say we've got a squared plus b squared equals c squared. And we can label these any way we want, as long as C is that longest side. The A and the B, that order doesn't really matter. So I'm just going to call the left one A and the bottom B. And filling in what we know, instead of A, we're going to write a 3. Instead of B, we're going to write 5.4. And then instead of C, we're going to write X. And this time I'm going to remember to put that square there that I missed last time. From there, we're going to our calculators. We're going to take 3 squared plus 5.4 squared, putting that directly in and seeing what we get. On my calculating device, I'm getting 38.16. Hopefully you're able to get the same. And last step, we have to take the square root of both of these sides so we get rid of that squaring, that power of 2. As a result, when I take the square root of 38.16 to the nearest tenth, I get 6.2. So make sure you can do the same. Take a moment now. Try the next 2 examples. They work just like this one. They're over on the next page. So try those 2. See how they go. Pause the video for about 4 or 5 minutes. And then resume to make sure your answers were okay. And you can do that now. All right. Assuming you've paused and come back, I'm going to tackle these examples. I've got an A, a B, and a C. The C's on the bottom there because the bottom's that longest side. So A squared plus B squared is equal to C squared. 19 squared plus 35 squared is equal to this X squared. I go to my trusty calculator. And I get 1586. And then I take the square root of both those sides. And I got, what did I get here? I got 39.8. And that's that one done. If you got that one correct, give yourself a way high five. And last one, C's right up here on the top. That's our hypotenuse. That's our longest side. So the other ones can be A and B. A squared plus B squared is equal to C squared. So 20 squared plus 20 squared is equal to X squared. And I put that into the calculator. I've got that X squared is 800. And I take the square root of that to tell me that X is 28.3-ish to the nearest tenth. So that's how we can proceed with the Pythagorean theorem very directly if we're trying to find the hypotenuse. In some examples, we're not trying to find a hypotenuse. In this example, the hypotenuse is given. It's given to us as 5, and it's one of the shorter lengths that we have to find. We still set up the same way. We'll start by saying A squared plus B squared is equal to C squared. And then we'll label these things. Remember, the side that we label as C has to be the hypotenuse. So this 5 has to be the C value there. The A and B don't really matter. We're going to replace them with an X and a 4 in whatever order momentarily. So let's get those in there. And now we can fill in what we know. So the A is 4. The b is actually an x. I'm going to remember the squared. And then the c is a 5. We need to get x entirely on its own. And there's stuff bugging it. For example, it's being bugged by the square. We know how to get rid of that with square rooting. But before we do that, we have to take off this 4 squared. So I'm going to subtract that from both sides. Based on the order of operations, this does not give you 1 squared. It's not 5 minus 4. Just leave it written exactly as it is. 5 squared minus 4 squared. Leave it like that and type that into your calculator. Typing it into your calculator, you will get 9. And then we'll have to take the square root of both sides. And your calculator will tell you that that gives us exactly 3. Take a moment, take 2 whole minutes, try the next example, see how it goes. It's probably an example where you have to round the final answer. Sure looks like it. Oops, somebody put a J and L in here for who knows what reason, so you can just scribble those out. But give it a try, and then fire up the video again. Alrighty, firing up video. C has to be the longest side. It's not one of these two sides because those two sides make up the 90-degree angle. It has to be the other one, which leaves the other two as A and B in whatever order. So, A squared plus B squared is equal to C squared. X squared plus 12.1 squared is 32.3 squared. I'm going to take away this 12.1 squared from both sides. And on the left, that leaves me with x squared. On the right, I'm just keeping that exactly as it is. And I'll let the calculator do the processing for me. So I'm going to take this, I'm going to find 32.3 squared and subtract 12.1 squared. And according to the calculator, that is 896.88. There we take the square root of both sides. That's our usual. Oops, I did the wrong button. And I get 29.9. So that's how we can use the Pythagorean theorem to find side lengths, whether we're finding the hypotenuse or we're given the hypotenuse and need to find another length. As I mentioned in the beginning of the video, we can also use the Pythagorean theorem to determine whether a given triangle actually is a right triangle. And for that, we want to check if a squared plus b squared equals c squared. So in a case like this, we're going to break this into two parts. We're going to look at a squared plus b squared, and we're also going to look at c squared. A squared plus b squared for this example is 8 squared plus 15 squared. That's what's given to us by the question. Just straight up by this, a is 8 and this b is 15. And let the calculator do the work here. 8 squared plus 15 squared. According to the calculator, that's 289. C squared, we're going to use this value of c that's given to us. And that is 17 squared then. So c squared is 17 squared. And again, let the calculator do the work. We find out what 17 squared is. And that gets us also 289. So a squared plus b squared does equal c squared. Thus, we can say since a squared plus b squared equals c squared, this is a right triangle. Take a moment, try the other two examples on this page. This last one doesn't have A, B, and C given to us, so we're going to have to label them based on what we guess is happening. But try them out, see what you get, and in about 4 minutes, resume the video and check your work against it. All right, assuming you have checked things over, or at least tried the examples, let's see what we've got. We're going to look at a squared plus b squared, and we're also going to look at c squared. A squared plus b squared is 10 squared plus 40 squared. And, whoop, I dropped my calculator. According to the calculator, this is 1700. C squared oops, is 41 squared. And according to the calculator, that's 1681. These two values are not the same. So, as a conclusion, we'll say, since a squared plus b squared does not equal c squared, this is not a right triangle. And the last one, we'll have to label things again just to excuse me, sorry about that. Just so we can see what's going on. When we label things, we're not going to label one of these two sides as the C value, because the C value, if this is a right triangle, the C has to be our hypotenuse, and it has to be the longest side. So I'm going to put the 37 as the C value in this case. The A and B don't really matter as much, so I'll just label one of these as A, one of these as B, as long as we make sure that the C is the longest one, the hypotenuse. And we'll check this. We'll check a squared plus b squared, and we'll check c squared. Now again, you tried this while you took a pause in the video, so at this point you're just verifying that you did the same thing. 12 squared plus 35 squared. And according to my calculator, 12 squared plus 35 squared is 1369. C is 37, so C squared is 37 squared. And according to my calculator, that is 1369 as well. So we did get the same thing. So in conclusion, a squared plus b squared does equal c squared. This is a right triangle. So that's it for this lesson. Hopefully you found it okay. I apologize that it had to be on video. We will continue with trigonometry. We'll look at some of the new stuff with angles and whatnot as this unit progresses. If you have questions, just message me on Teams. There is some practice work for you to try, so try those out. And hopefully they go okay. I hope to see you soon. Be good to yourselves, be good to one another, and see you in the future. The end.